Good morning, everyone. Thank you guys for joining. Hope you can hear me well. If you can't hear me, please ask a question. Feel free to ask questions throughout the presentation. Uh, I will answer questions at the end of the presentation, but if you'd like to ask your questions early, feel free, and I'll go through them at the end. My name is Colin Lowenberg, and I'm a product marketing manager at Sumo Logic, and I'm going to talk to you today about observability, what that means, and then I'm going to walk you from end to end how to use Sumo Logic's platform to find and resolve an issue with an application. So if you are not familiar with Sumo Logic, we recently actually went public, and we are the premier solution or platform for continuous intelligence. Continuous intelligence is beyond business intelligence and more than just real-time analytics, but rather capturing all of the information about your applications and services and providing them in a platform that allows you to pull out information and see the signals from the noise. As you can see, we've got quite a bit of customers from older customers that have migrated from on-premise and more traditional infrastructure to now migrating to the cloud, like United and ABI InBev, as well as we've got customers that are built cloud native, like Airbnb and Netflix, who have really built their companies in the sort of modern application infrastructure way. So we've got a wide range of customers. So wherever you are in your cloud journey, whether you're starting all cloud and nothing but, or you're still migrating from on-premise to cloud, Sumo Logic has customers very similar to you. If you aren't familiar with what Sumo Logic's platform can do, we collect information from all of your different services and applications in the cloud or on-premise, and then we monitor all of those logs, metrics, and traces, as well as other metadata that comes from APIs from your different cloud providers or on-premise servers. We also help you diagnose what issues impacting those services and applications. So we're going to actually dive into a real-time demo of, or real live demo of diagnosing an issue. And then we also help troubleshoot and find the root cause of an issue and help you restore service and remediate. So that can be also a really critical thing. We're not just a monitoring tool, we're also a troubleshooting and diagnosis tool. So today I'm going to walk through a live demo of our platform and right after this slide. But before we dive into the live demo, I want you to kind of get a feel for what it would be like to be the SRE or the site reliability engineer or backend engineer, infra engineer, or just the on-call IT guy who's got to manage this application and respond to issues that are occurring. So we built our application for this demo and launched it on our demo cloud. We run it on AWS and we use Kubernetes to scale it up. And it has an ELB load balancer, which protects a payment service. So that obviously, since it's a payment service, it's probably going to be mission critical. And that payment service runs on different pods on our Kubernetes deployment. And then that payment service actually calls to an account service as well. So if we have two different services that are talking to each other, and then we have a database backing that account service, which makes a lot of sense. All your account information is stored in a database, so the account service is calling an RDS database. Again, all this is on Kubernetes, AWS, and Java. So it's a pretty typical application, and we just went ahead and built this application just to show this off. But all of our customers are using somewhat similar infrastructure. And we have a pretty high adoption of AWS as well as Kubernetes within our customer base. So a typical troubleshooting issue might start with an email such as this. And I'm going to switch over to the live view now and actually pull up my email just so you can see. This is an actual email alert from Sumo Logic's platform saying, hey, you've got an issue, critical alert on the payment service. It's beyond 5% on your service level objective or SLO error. Now, there's some monitor query here. It shows this is the query that's triggering this monitor email. maybe you can't read this query yourself, but it is relatively easy to understand what it's trying to say. We've got errors, and the number of errors is greater in the last 10 minutes than 5% than it has been in the past. And so we're passing that SLO, or we've gone beyond our service level objective. So we can immediately click this link right here, which will link us right to the dashboard right here. This is our payment service error dashboard. Now, you might say, oh, wow, that's a really cool dashboard. We actually built this dashboard for this demo, but you can build your own dashboard to do something very similar. Very easily. So very customizable dashboards. You can display the error rate. You can see here we've got 32%. And we can also graph the error rate. This blue line right here, we're graphing the error rate over time. And then automatically, Sumo Logic will determine a threshold. And that's what this pink line is right here. This is the threshold that's automatically computed as a baseline for the number of error, for the percentage of errors. So if the blue line gets out of the pink, then you can see that we have an outlier. So this graph shows error rate outliers, so you can see when the issue began, so we can help identify what time frame we should focus on when we're investigating and troubleshooting the issue. So this is an interesting way to look at an error happening, and as it goes beyond its normal percentage of errors, then you can identify that outlier and when it occurred. Now, obviously, when you're troubleshooting issue, you need more than just a timestamp and to dive into the logs. That's certainly one way you could do it. You could just start searching the logs, but we want to actually do a little bit more, and we're going to look at the customers affected. Let me hit refresh. Looks like I got an artifact there. Just close it. Sorry, I'm just reopening that one. Oh, looks like that's from another page. 1 second. There we go. Sorry about that. I just had something hovering over. So if we look at those payment service errors, we can see that this error rate plateaus right here. And we can also scroll down to see customers impacted. So I pulled out the list of customers that are impacted by this SLO being breached. And we can see the names of those customers, their location. Now I could reach out to my support team and tell my support team, hey, maybe we reach out to these customers, let them know what's happening, or we just ping them and see if they're having any issues. Also, we can see error signatures immediately right here. This is kind of a little bit of a cheat because we're seeing right here connection refused errors. So immediately right here, we have these error signatures. But rather than jump to this cheat code that we have added to this dashboard, I'm going to show you how you could find this connection refused error in the logs and where you might find how you might solve this problem without just this tile telling you here's a problem. So as well, when you're looking at an issue, you want to understand not just how it's affecting your customers, but how severe the issue is for you and your business. So if we look at the transaction volume, when this issue is occurring, we see the transaction volume drop significantly from over 118 transactions per minute to under 10 transactions per minute. As well, that affects the dollars transferred. So we can look at the health of our business. This is that BI flare that you get with Sumo Logic. I can see the number of dollars transferred has dropped from over $30,000 a minute in transferred money to under 2,000. So we've got a major problem. This is actually impacting, and I don't have time to wait to investigate this. I need to start resolving and remediating this. Now, we can also graph the error rate by pod. So this is honeycomb view, lets me see all of the pods in my Kubernetes deployment easily. And I can see some are not having as many errors and others are, and I can click on those pods to get more infrastructure information on the right. And I can actually see the memory used, the CPU usage, and I can see, okay, well, this one has a higher error rate than this one. Do I want to dive into this one pod? No. In this case, we have so many pods across our deployment having the issue. We really want to drill up, or not drill down, but rather pull up to the 10,000 square foot view. And I want to see the entire deployment. So we pull out that contextual information about your infrastructure into Sumo Logic structure of our dashboard. So you can look at this infrastructure tab here, and you can see the payment service container, and then I can see the payment service pod, and I can see the payment service deployment. So I can look at all 41 pods right here, and I can look at the entity dashboard, the raw logs, the traces, and the metrics. So you have metrics, traces, and logs all easily accessible right here on the right. But before we dive into metrics, traces, and logs, we want to look at our new entity dashboard. So if you click on entity dashboard for the deployment, what that will pull up is this Kubernetes view of our entire deployment. And I can see the number of pods that we have. We have 40 pods running. There's 2 offline, and I see a very big red connection errors going on right now. Now, we can also graph those connection errors if you prefer not to have these little snazzy metrics. You can also pull up just a simple table of listing all your connection errors and the count of those types of connection errors. So you can see connection refused, 45,000, and you could graph it out too. So there's any number of ways that you could display the data that we provide you, and that's fully customizable. Now, I kind of like the little chart over here because you can have red, yellow, green, and you can set what thresholds you want to focus on. Now, since we see this connection refuse error, I'm going to click on that connection refuse error, and I want to see more information about that. Now, going back to our architecture, the payment service is talking to the account service, right? So if we look at this, this is actually the connection refused to the accounts service. So our payment service, and we're looking at the deployment for the payment service right here. You see payment service. So the payment service is having a failure to, or being refused by the account service. So I can actually go over here, and what I want to do, rather than look at logs or metrics, I want to look at traces. If you're not familiar with traces, traces are essentially a way to collect all the transactional information about a specific transaction. So any user and all of the steps that they're taking within your application. So this is the traces view for the account service talking to the payment service. And if I click that link right there, it automatically takes me to this traces view right here. And I can see the payment service talking to the account service. And each one of these lines on here is a different transaction trace. So it'll contain all of these steps that occur for a specific user or specific steps through our application. Now, for a distributed application with microservices and Kubernetes, you're collecting a lot of data from different services. So traces is the best way to look at 2 services talking to each other. Now, I can see here there's some payment service and account service here. So I'm going to just click on that, and it takes me to this view where I can see the account service is 80% of the time, and the payment service is 20% of the time here. And I can see there's errors. We're seeing the payment service is doing an HTTP GET right here, and we can see each step of the application that the application is taking. It's doing a GET to the account service, looking for a name, GET account, and then find by ID. So we can see sort of the programmatic steps that are happening. Now, if you were to look at this for another application, I just wanted you to see what it might look like if you had a more complex application. So this is another application we built for a demo, and the coffee lover application. You can see there's a coffee bar talking to a coffee machine, also talking to a cash desk, also talking to a service machine. So you can see there's quite a bit of different services that are coming into play here, and you can see them talking to each other. Now, there's no errors on this trace view, but if we look at the trace view for our payment service, you can see there are errors on each and every one of these bars in red. Now, if I click on red, click on the last bar, find by ID, I can see the account service again right over here. I have these 4 powerful little buttons. In this case, I want to just dive into the logs for this one specific container that's having this one specific issue. And that really helps me drill down to a very tiny little bit of log data, so I don't have to be surrounded by tons and tons of logs. So as I pull up that log data, I can immediately see that there is an error right here that's unable to acquire JDBC connection with root cause. Can't be that easy. And there are 152 pages of logs. It's a lot of logs. So we can keep going through it. I keep seeing that same error, but I don't know how frequent any one of these errors is. So we have a special feature that Sumo Logic has created that uses machine learning to actually go through all the logs for me and find the commonalities between them. So it does pattern matching or pattern recognition, and then sorts through them and simplifies that 152 pages of logs and sorts it out to a single page. And now I can see how many times similar errors have occurred. And so this way, this is kind of what I would do. Simplify your logs, look at the commonalities in it, and take out the timestamps and things that make each log just slightly different from each other. I can see there's several logs that start with root cause. So I see that right here, that same one. I'm going to expand on it right here. And when I expand on it, now I can see this is the same unable to acquire JDBC connection, or that's a Java database connection with root cause. And it says the root cause is too many connections. Great, I've got a root cause, problem solved. I can say, hey, we've got too many connections on that SQL database or RDS database. So let's go increase the number of connections allowed. And then let's, what else can we do? I'm done. I can go to sleep. However, we know that's probably not the root cause that's causing the problem. Too many connections is why it's getting refused, but the real root cause is not that we just didn't increase the number of connections or enough memory on that RDS database. We want to investigate a little bit more what's happening, what might be causing that too many connections error to occur. So I can't accept this as a cause, just call it a remedial root cause for right now. So in order to find the true root cause, we're actually going to use a relatively new feature of Sumo Logic called the Root Cause Explorer. And I'm jumping to the Root Cause Explorer now, and I'm looking at the last 24 hours. I can change the time frame right over here, and I can see errors on this screen graphed out. So I can see on the x-axis is time, and I can see what time the issue occurred, and the y-axis, I can see the percentage drift from the norm. Now, the percentage drift is the drift from the normal baseline for any metric. So I'm actually looking at not log data, not trace data, as we were looking at before, but rather the metrics. So these are the metrics that are being collected directly from the AWS applications and servers. And I can see right here, I've got a Lambda error that's drifting for 10 minutes. It's almost 800% over normal. I can see ELB, the load balancer, is having a throughput issue. I can see RDS is having an issue on MySQL 2, and RDS is having an issue on MySQL 2 here again. So it's over 10,000% drift for the last 30-minute period. So this is pretty clearly related to the time frame, as well as just the root cause, which we know was too many connections to the RDS database. So how do we dive into this? Well, we can click on that little dot, and we can actually see the metric over time. So you can see the metric shooting right up at this time. And we can also dive, we can see the type, the entity, where it is. So we now have the infrastructure information. I could ping the owner of this infrastructure and say, hey, can you increase the memory on this specific server? Now, we know that the problem is not just too many connection errors, because that's just too simple. So let's dive into the error logs for the RDS database just by clicking all logs from here. Now, when we go to this page, when we click out the all logs here, I'll actually click it for you. Click on all logs, and you can see automatically we pull up this list of errors, and you can see we've got the number of a number of errors that are very similar. And if you look at them, what we're looking at is actually queries. These are SQL queries saying update inventory, another one saying update inventory. Looks like quite a bit of similar queries. This one's doing a select from inventory, but these are slow queries. So they're being put into a log group called slow query. So we're detecting slow queries on our MySQL RDS database. And now we know, okay, these queries are what's causing slow connections or too many connections. They're taking too long, and we're overloading the number of connections. Makes a lot of sense. We found the real root cause. I can go to my development team and say, hey guys, take a look at these queries. Can you fix them? Can you, do some magic, redoing the tables to make them more efficient? Can you rewrite the queries to make them slightly faster and reduce the time that these connections are taking? Problem solved, right? However, I don't know if you know development, it doesn't happen overnight. So they might not be able to fix this issue immediately. And we know from back from our original payment service error that this is actually impacting our entire transaction volume and dollars transferred. So while I can get us back to working just by increasing the number of connections temporarily, I can resolve this issue at least for the time being before my developers can go and fix those slow queries. So what am I going to do? Well, I'm going to take these slow queries and I'm going to actually set a alert to detect when the slow queries start to happen. And in this way, I can predict the issue and prevent it from causing a slowdown in our transaction volume and actually affecting our customers. So I'm going to go to the alerts panel of Sumo Logic and click on my folder right here. And I can see my original errors, the payment service error over 5%, critical error. And I can also see the predict slow query time. So I created this in advance, but essentially we take the same query that we use to detect the slow queries, and we take that search and we put that into our trigger condition. So we're looking for any slow query that takes over a specific time. And we sum that up over time and we say, how many times does this occur in 5 minutes? So if we see 10 slow queries in 5 minutes, then we want to send a notification. So I'm going to send an email to myself and the other on-call SREs, and then send myself some information. Say, hey, I'm predicting that the slow queries are going to be too slow relative to the database capacity. This is going to take over and cause issues for customers. So what you should do is increase the number of connections and find the slow queries affecting. So now we've gone from from finding an error in an email, and we just know that there's too many errors, to diving into the to our nice payment service error SLO page. We found the errors, we found the customers affected, and then we drilled down into the logs. We looked into the traces, and then we looked into a true root cause, which led us to actually the RDS database being the issue. So in this way, we've actually solved the problem in just this short 20-minute demo. We've been able to find an issue, detect it, and resolve it. So if you aren't familiar with observability, I hope you feel a little bit more comfortable now. A key thing to understand observability is not just monitoring, but observability really is with a goal of reliability. And reliability you can measure in performance, availability, or security. Those are all things that can affect the customer experience, but reliability is more critical than anything because it provides support for all of that. And observability is the ability to take all of the data, the logs, metrics, and traces, and then enabling someone to actually view all that information in a single platform and then troubleshoot and find the issue and the true root cause. So I hope you guys enjoyed going through the process. If you have any questions, I'm going to go ahead and jump into the questions section, and I'll leave the root cause explorer open. I see one question. The calculated threshold seems to be too high. How is it computed? I'm going to answer that one live. Because we only talked about one threshold, I'm going to assume Jorge is asking about the payment threshold for here. So we can see the threshold actually increases as the baseline changes. So the threshold is very low right here, and you can actually see the threshold is if it goes even above 0.13. So if it goes 30% above the baseline, then you're going to see errors. And then the outlier occurs, and it's at 31% errors. And then the threshold starts to change. And you can see right here, just after the outlier, the threshold has now actually changed to widen the gamut. So we don't keep getting the same alert over and over again. We're saying now the new baseline or the new threshold is now around 33.29. So we increase the threshold automatically so that you don't get the noisy alerts like payment service error, 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 error. So it helps to prevent that noise, and you can see when the first error rate SLO was violated. So I hope that was helpful. If there was a different threshold, please let me know. Great. Any other questions? All right, well, if you're looking to get started with Sumo Logic, sign up for a trial. And if you are already a Sumo Logic customer, I encourage you to try out the AWS observability. You can enable AWS observability app on your Sumo Logic to get access to the root cause explorer. As well, if you are using Kubernetes, then I encourage you to check out the Kubernetes deployment view. So if you're looking for these functions in your Sumo Logic dashboard, you may have to go to the apps and find Kubernetes and AWS observability. And that's how you can access these types of pages. All right, well, I really enjoyed talking to you guys. I see you can find a link in the chat for the trial. And if you have any questions, looks like we got another question. Can we do custom Explorer views for on-premise configurations? Yes. So this Explorer view, I'm going to answer that live. So this Explorer view right here is what comes sort of out of the box. So you can get when you select the Kubernetes deployment view, it automatically populates this left side here, and it pulls all this metadata out of your Kubernetes deployment and pulls it in here. So this is all automatically created for you. You can use Terragraph to pull all that information in really very quickly, and then you can customize and create your own custom dashboards on the right. So each one of these is customizable. I can change the size. As you can see, like with the connection errors, you could do a bar chart, you could do this graph, or you could do a table. So you can customize how you want to view that. Some people like the red, green. Some people just want to look at the data. Hope I answered your question. Can we also use Explorer View for non-Kubernetes orchestrations like Nomad? Yes, you can absolutely create similar views. In this case, this dashboard is designed specifically for Kubernetes and it's automated. I don't know. I don't know off the top of my head if we have a similar pre-built-in one for Nomad, but you can certainly copy this and link it up to something else. So I actually don't know the answer to that one fully, but yes, you could build a very similar one for Nomad. And a lot of things come out of the box and we're really focused on increasing your value and reducing the time to value. So a big feature of Sumo Logic is that a lot of things are built into our dashboards, and we have apps and dashboards pre-built in, so you don't have to go and build them for AWS installation specifically. We have a lot of things. Now, is there a similar feature for Azure versus AWS Observability? We do have an Azure app. AWS Observability is a major improvement on our AWS view. If you want to look at other apps, you can go into our app catalog while you're in the product, and you can find those other apps. In this case, we have AWS Azure Kubernetes control plane, and it comes with it looks like it comes with 3 different dashboards, an API server, a controller manager, and a scheduler. So you might consider looking at the AWS observability and Kubernetes for AWS and reuse that. The Kubernetes deployment view should work for your Azure. Now, if I'm not Kubernetes, but I have my on-premise VM infrastructure not using Kubernetes, can you define a custom Explore definition of relations of objects? Yes. You absolutely can use this with on-premise. Approximately, I can pull up a quick chart for you. I can tell you exactly how many customers are using our infrastructure with their on-premise applications. So this is from a different presentation, but I just want to share some quick data from one of our from our customers. So this is our customer base right here. Loading. So 59% of our customers are AWS only, which is kind of why we focus on it in this demo. But 15% of our customers are still using on-prem, and that's fine, and we fully support that. We are not, cloud only for our customers. We are completely cloud-based, and all of our infrastructure is actually running on AWS as well. And a lot of our customers are actually sort of in that in between. So we've seen a huge growth in multi-cloud customers over the last year. It's grown from, I think, 13 to 14% to 18%. There's a pretty significant growth in the multi-cloud, as well as customers using AWS plus Azure, or AWS plus GCP, or even customers using both AWS and GCP. We've actually seen for customers that use all three clouds, almost 88% of our customers are using Kubernetes. So Kubernetes is pretty popular among the customers that are actually doing multiple clouds. Let me go back to any other questions. I hope I answered your questions. If I didn't, feel free to re-ask them. All right, guys. Well, I really appreciate talking to you guys today. I do have another meeting to go to, but if you want to reach out and chat further with us, reach out to our sales team or technical support team and ask us any questions you want. Thank you guys for your time.